Assalamu alaikum. This is Muhammad Mahid Khan Amir, lecturer in mathematics, EMDS, Rajaguttura Model College. Today our class is on general mathematics for class 9 and 10. So once again welcome in the class. Our today's class is on logarithm, which is in your book exercise 4.2. So first thing we need to know in this chapter is the definition of logarithm. What is logarithm? This is kind of the exact opposite of index, as plus is opposite of minus, that kind of things. If a to the power x equals to n, where a is greater than 0 and a is not equals to 1, then x equals to log a base n is defined as a based log a n. It can be normally said as or spelled as log a n or log a based n. So this is our definition. If ax equals to n, a is greater than 0 and a is not equals to 1, then x equals to log a base n. If you see in the two parts, the base is always a, so there is no change in the base. X was the power in our first part and n was the solution. Here x is the solution and n is used as a power of logarithm. We need to know this definition very well because we can solve some maths using directly this definition. For example, for 10 square is equals to 100, then 2 equals to log 10 based 100. Again, for e to the power 0 equals to 1, then 0 equals to log e based n, that is equals to log ln n. When our base is e, then log is written as ln. Normally, if the base is not given, we will let our base is 10. Here base can be anything except 0, sorry, except 1, because we have seen that in condition it is cleared a will be greater than 0 and a will not be equals to 1. So according to that definition, in our base can be everything without negative or 1. This was our definition. Like the previous chapter, we need to know some laws of logarithm. They are kind of same. First thing is 0 log. If a is greater than 0 and a is not equals to 1, then log a based 1 is equals to 0. Normally we have known that a to the power 0 or something to the power 0 equals to 1. So from there come this log a to the power n or log a based 1 equals to 0. Next one is 1 log. If a is greater than 0 and a is not equals to 1, log a based a equals to 1. In the definition of 1 index or 0 index, we have learned the similar condition. There were also the similar conditions. Next theorem, next laws is log of product. Log a based mn is equals to log a based m plus log a based n. The next one is log of quotient, that is log a based m by n is equals to log a based m minus log a based n. This log of product and log of quotient is kind of same. When there is multiplication, there will be plus, and if there is division, then the minus sign will be used. Next one is log of power law. Log a to the power m to the power r equals to r log a based m or r log a to the power m. Next one is change of base. We can change the base of the given logarithm if we want. So there is this law is for that. Log a based m is equals to log b based m into log a based b. That is, we have introduced a new base b for m. So log b based m is into log a based b. Now we have a corollary which will be used as a law or formula. Log b based a is equals to 1 by log a based b. So if we want to interchange the base and the power, we have to reciprocate it. Now we are going to our exercise 4.2. Number 1, find the value 1 log 3 based 81. So we have to find the values, or in simple word, we have to simplify this kind of maths. These are very easy maths, or this chapter is rather very easy. Number of maths in this chapter are very little. So log 3 based 81. Solution given. We have to write the given line log 3 based 81. So here we can simplify, or if we want to prime factorize 81, we can write 81 like 9 into 9. Though 9 is not a prime factor, 9 can be prime factorized. That will be 3 square. So 3 square into 3 square, that is 3 to the power 4. Or 81 is equals to 3 to the power 4. Using that, we can write log 3 based 3 to the power 4. Now, as the log law of power states that log a based m to the power r is equals to r to the r into log a based m, or in simple word, we can write the power in front of the log. So here we have log 3 based 3 to the power 4, as 4 is our power here, so we can write the 4 in front of the logarithm. So doing that, 4 log 3 base 3, as we have taken 4 in front, in the front, or in at front. So log 3 base 3 to the power 4 is equals to 4 log 3 to the power 3. And inside note, we have written why we have write this as log a to the power m to the power r equals to r log a to the power m. Now again, we have learned the one log formula, which was log a based a is equals to 1. Here we have got log 3 based 3, so 4 into 1, as log 3 base 3 is equals to 1. Why? Because according to the formula, log a base a equals to 1. So if we replace a by 3, it will be log 3 base 3. So that is also 1. Now 4 into 1 is equals to 4. So this is our solution, or the value of log 3 based 81. Giving you a few seconds to recheck it. Next math, number 3 of number 1. Find the value log 4 based 2. So in the solution part, we have written the given line, or given equation, or given term log 4 based 2. So for this kind of maths, we have to rewrite our power as like as our based, or we want a base and same base and same power. So for that, we want to convert 2 into 4. How can we convert 2 into 4? We know root over 4 is equals to 2. So 4 to the power half is equals to 2. So we can replace 2 by root over 4, or 4 to the power half. So doing that, we will have log 4 based 4 to the power half. So we could successfully replace our 2 with 4. Why we have done this? Because we want to have the same base and the same power to apply the formula of log a based a. So now we have log 4 based 4 to the power half. As we know, we can take the power away from 4 and write it in front of the logarithm. According to the formula of log a based m to the power r is equals to r into log a based m. So according to that, log 4 based 4 to the power half is equals to half log 4 based 4, as log a m to the power r equals to r log a m. Now we can easily see, or we can see that log 4 base 4, which is as same as log a base a, which was equals to 1. So log 4 base 4 is equals to 1. So our next line will be half into 1, as log a base a equals to 1. Now multiplying half with 1, we will have half. So this is our required value of number 3, which was log 4 base 2. A few seconds is given for you to write or recheck. Next one is number 5 of number 1. They are very easy maths in number 1, obviously. So find the value of log 5 base cubic root of 5 into cubic square root of 5. So we have to do something what we have learned in chapter 4.1. So solution part, the given term is written log 5 base cubic root of 5 into square root of 5. So now the powers or the cubes, sorry, the roots can be written as 1 by that part. So we know root over 5 can be written as 5 to the power half, and cubic root of 5 can be written as 5 to the power 1 by 3, as we learned from the nth root of a was equals to 1 a to the power 1 by n. So applying that, we have log 5 based 5 to the power 1 by 3 into 5 to the power half. Now we have same base 5 and a multiplication sign in between them, so we can add the powers of 5 in the next line. So doing that, we will have log 5 based 5 to the power, and adding 1 by 3 plus 1 by 2, we need to do some LCMs to add the fractions. So doing that, we will have 2 plus 3 divided by 6. So adding them, we will have log 5 based 5 to the power 5 by 6. Now we can see we have a power term after the logarithm, so we can take the power away from the 5 and write it in the front. So 5 by 6 into log 5 based 5, as the formula is log a based m to the power r is equals to r log a based m. Now we can apply the formula of log a based a, which is 1. So according to that, log 5 based 5 is 1. So 5 by 6 into 1, as log a based a equals to 1. So multiplying 1 with 5 by 6, we will have 5 by 6. So this is the solution of our number 5 of number 1, which is equal to 5 by 6. These are very easy maths. When I was a student of class 9 or 10, I used to do this math for over and over again. I loved this chapter, these two chapters actually, 4.1 and 4.2. Though I hated 4.3. So next math is number 2. Find the value of x, and one is log 5 base x equals to 3. When we were learning or reading the definition of logarithm, I have said that we have to apply that formula directly to solve our maths. This one is that kind of math where we will apply directly the formula of logarithm. In the formula of logarithm, we have learned if a to the power x equals to n, then x equals to log a based n. So solution, given that log 5 based x equals to 3, so according to that formula, here we can write 5 to the power 3 equals to 1. I have said the base will be same, so write the base 5, then powers will be interchanged. So 5 to the power 3 will be equals to 5, or x equals to 5 cube. How we have written this? We have written this from the definition of logarithm. Don't be confused writing this line. Now 5 cube is 125. So the value of x is equals to 125. So this is our required solution of x. Next one is number 3 of number 2. Find the value of x when log x to the power 1 by 16 equals to minus 2. So similarly, doing this math solution, given that log x to the power 1 by 16 equals to minus 2. So according to the definition of logarithm, log a based n equals to x can be replaced by a to the power x equals to n. So from there, the base will be same and the powers will be interchanged. So x to the power minus 2 will be equals to 1 by 16. As we have known that the x to the power minus or a to the power minus n is equals to 1 by a to the power n. So applying that formula, we will have x to the power minus 2 as 1 by x square. So 1 by x square is equals to 1 by 16. Now if we want to reciprocate the both the parts, both the sides of the equation, we can write x square equals to 16. Now doing the square root in both the sides, we will have x square equals to 16 square. 16 can be written as 4 square. So square rooting, if we do square root in both the sides, we will have x equals to 4. So this is our required solution. Next math is number 3. And first we have to show that 5 log 10 base 5 minus log 10 base 25 equals to log 10 base 125. As this is a kind of proof, so we have to start it from the left hand side or right hand side. So for this particular math, we will start from left hand side. So solution, left hand side equals to 5 log 10 base 5 minus log 10 base 25. This kind of maths are very easy. So first thing we need to do, look at the first term, 5 log 10 base 5. So we have to take the 5 from the in front and we will put it in at the power place of 5, as according to the formula r log a based m equals to log a based m to the power r. So doing that, 5 log 10 based 5 will be replaced by log 10 based 5 to the power 5 minus the second part, we can rewrite 25 as 5 square. So minus log 10 based 5 square, as log a m to the power r is equals to r log a based m. Now we can see here we have two parts, log 10 5 based 5, sorry, log 10 based 5 to the power 5 minus log 10 based 5 square. So we can apply the formula of log a based m by n, which is equals to log a based m minus log a based n. So doing that, we will have log 10 based 5 to the power 5 minus 5 square. So just minus will be replaced by division. Now 5 to the power 5 divided by 5 square, which we can apply the formula of a to the power m divided by a to the power n, which was like equals to a to the power m minus n, the power of numerator minus the power of denominator. So according to that, log 10 based 5 to the power 5 minus 2. And doing the calculation in the power term, we will have log 10 based 5 cube. And we know the value of 5 cube is 125. So log 10 based 5 cube will be equals to log 10 based 125, which is our right hand side. So we got left hand side is equals to right hand side. That is 5 log 10 based 5 minus 10 log 10 based 25 is equals to log 10 based 125. Giving you a few seconds for you to recheck. So that's all for today's class. We need to, if we want to do well, or if we want to be master of this maths from chapter 4.2, we have to practice the formulas from both chapter 4.2 and chapter 4.1, or the laws of index and the laws of logarithms. So thank you all for joining our class. Allah Hafiz.